In this problem, we're going to take an integral and convert it into Newton's notation and then evaluate it using a limit and a summation. So the integral we're given here is the integral from 0 to 3 of 2x plus 1 dx. And the formula that we're going to use is Newton's notation for an integral, which is a limit as n approaches infinity of the sum from k equals 1 to n of f of x sub k times delta x. Now the f of x sub k times the delta x is the widths and the heights of the rectangles that we would get if we were doing a rectangular approximation of this integral. So f of x sub k represents the height of each rectangle, and delta x represents the width of each rectangle. We're going to multiply those together to get the area of each of the rectangles. And then we'll sum all of those rectangles' areas together from k equals 1 to n, for us having n rectangles, and find the limit as n approaches infinity. And that will give us an exact value for the area underneath the curve. So our delta x value is always equal to b minus a over n, which in this case is 3 minus 0 over n, or just 3 over n. And our x sub k value is always equal to a plus k times delta x, which will be, in this case, 0 plus 3 over n times k, or just 3k over n. So first off, we will replace the x in our integral with x sub k, giving us a limit as n approaches infinity of the sum from k equals 1 to n of 2 times x sub k plus 1 delta x. And then we will replace those values of x sub k and delta x with our given values for this particular equation. So that will give us the limit as n approaches infinity of the sum from k equals 1 to n of 2 times 3k over n plus 1 times 3 over n. From there, we just need to multiply the 3k over n times the 2 and then distribute the 3 over n to it. This gives us the limit as n approaches infinity of the sum from k equals 1 to n of 18k over n squared plus 3 over n, which we can separate into two different summations. The limit as n approaches infinity of the sum of k equals 1 to n of 18k over n squared plus the sum from k equals 1 to n of 3 over n. From there, all we have to do is use a known formula to sum together integers, that the sum from k equals 1 to n of k is equal to n times n plus 1 over 2. Replace that in our first summation, and then in our second summation, since we are just summing together a bunch of constants, 3 over n being a constant, from the first to the nth, when we have n constants, we have 3 over n times n. Putting those together, we can see that they are both rational functions, and since they're both rational functions, we look at the degree of each of them as we are looking at the limit as n approaches infinity, and the degree of 18n times n plus 1 over 2n squared in the numerator is 2, and the degree in the denominator is 2. So to find the limit as n approaches infinity, we just divide the leading coefficients to get 9. And for 3n over n, the degrees are both 1, and we divide the leading coefficients to get 3. So we end up with the sum of 9 plus 3, which is 12. And that's our final answer.